Okay, solving trig equations with an exact valued solution, right? Which means the whole unit circle, blah, 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 you know, pi over 3s, pi over 2s, over 4s, over 6s, all that good stuff. So, a trig equation got to have an equal sign, right? It's equal to something. And then you can solve it, right? So there's some values of theta that will make this true. Or this, or this, or this. And some of these trig equations have solutions that are exact values, right? Which means we can work them out. So we're going to get numbers like 0, 1/2, root 2 over 2, root 3 over 2, or 1. Right? Those are our exact values. Okay. Previously, you solved graphically. So, for example, solve 2 sine theta plus 4 equals 3. We could graph y1. We could graph the left side as y1. Is it plugged in? Oh, there's a number of 2's there. So 2 sine theta plus 4, and we could graph y2 as 3. And then we would look for the x-coordinates of the point, then determine the x-coordinates of what? Points of intersection, right? So in a graphical determine, we would have to show appropriate work. And the appropriate work would be y1 is 2 sine theta plus 4, and y2 is 3. And here's the window I'm working in. Right, and then the question is the domain restricted or not? But it's not always possible to determine exact value solutions for trig equations graphically. I mean, it's almost impossible graphically because you're just going to get a decimal. But algebraic solutions can lead to exact values. Since trig functions are periodic, there may be how many solutions? Infinitely many. For a trig equation. So unless the domain for the solutions is restricted, a statement regarding the what? What do we call the solution if it's not a specific solution? General solution. So a statement regarding the general solution for the equation. One thing to watch out for, and I suppose especially on multiple choice, is if the domain is restricted. You know, is it like negative 2 pi to 2 pi, and then is it less than or equal to, and another less than or equal to, is it strictly less than? In other words, part of the domain may not be included. If it's strictly less than, it's not included. And that might be a solution, and in which case you don't want to state. You know, if it says between 0 and 2 pi, so what I mean is there's a difference between this and this, and this, right? So if the solution is 0 and 2 pi, it won't be included here. It will be both the 0 and the 2 pi. And a lot of times you might see 0 but not 2 pi, because they're the same thing, right? So really, here we're including neither, here we're including both, although 0 and 2 pi are coterminal. So if 0 is the solution, so is 2 pi. And here, you know, as a multiple choice, we could say 2 pi is the answer, and it's not in this particular case. So you've got to watch out for restrictions on the domain. Okay, sometimes they can be a little tricky. Some algebraic solutions require factoring, right? So we're going to solve something. Just imagine this is equal to 0, and the solution is going to involve factoring. So what can we factor in this first equation? Sine theta, right? So there's a common, and if you're ever doubtful, just say this is like x squared plus xy. Okay, like just do a little stand-in thing. It's like x squared plus xy. So it's sine theta times sine theta plus cos theta. That's a factor. The second one, it's a quadratic in cos theta, right? Usually we do quadratics in x. But this is no different than 2x squared minus 7x plus 3. Okay. As a matter of fact, you could write 2x squared minus 7x plus 3, and you could factor that. So 3, 7. Okay, and then you say, well, wait a second, then there was no x's. There never were any x's in there. So it's 2 cos theta minus 1 and cos theta minus 3, right? Just take this out. That was on your scrap paper somewhere. Anytime you factor, check. So here, 2 cos theta times 2 cos theta times cos theta is 2 cos squared theta. Minus 6 cos theta minus 1 is minus 7 cos theta plus 3. And what do we do for this? 4 sine squared x minus 1. Okay, so just think of this, if you like, as 4a squared minus 1. That's going to be 2a, but there are no a's. Okay, so you can solve a simpler problem, right? It says 2a plus 1, 2a minus 1, simple difference of square. Okay, and then excuse me, there's 2 sine x plus 1, 2 sine x minus. And again, check. 4 sine squared x minus 2 sine x plus that's gone, minus 1. Yeah, it's all good. Little equal sign here. They are equal. Algebraically solve the following equations for the indicated domain. So if it's in radians, do your solutions in radians. If it's in degrees, do your solution in degrees. Okay, so always stick with the units that are given. So 2 sine theta plus 4 is equal to 3. What we want to do is isolate this, right? Get sine theta equals. And we know that sine theta is going to be equal if it's exact values. And today is all about exact values. Today's all about exact values. Then we're going to end up with sine theta equals 0, or sine theta is a half, or it's root 2 over 2, or it's root 3 over 2, or it's 1, or it's any of the above, but with negatives. Okay? So what are we going to get? 2 sine theta. What's 2 sine theta equal to? So what's sine theta equal to? Minus 1/2. And then this goes back to like the first day of trig, right? Or somewhere, the early days of trig. Seems a while ago, doesn't it? Right? When did you first start doing? I don't think we've ever done anything but trig. So this goes back to the early days of trig, right? And so you look at this and you say, okay, sine theta is negative, so I'm in quadrant 3 or quadrant 4, right? Need a quadrant 3 or 4 angle. Okay, I'm going to solve sine theta is a half, right? Or say the sine of the reference angle. So what's the reference angle for a half? Keeping in mind that here, it's, oh look, it doesn't include 0, which doesn't matter because 0 is not a solution to this, but. So, what's theta?
7 pi over 6, 11 pi.
Well, you leapt ahead, so sorry. Yes, that's theta. What's theta r? So the reference angle is pi over 6, but it's in Q3 or Q4, so theta is 7 pi over 6. Okay, so if you like, you can draw yourself a little diagram, right? Well, that's pi over 6. Oh no, sorry, we're in 3 or 4, right? If you like, you can draw a little diagram. And there's theta is 7 pi over 6. And over here, that's a pi over 6, so 11 pi over 6. Okay, and that's a specific solution in that domain. General solution, 7 pi over 6 plus 2n pi, 11 pi over 6 plus 2n pi. That would be your general solution, where n belongs to the integers. Okay. 2 cos squared theta minus 7 cos theta equals negative 3. Okay, so you go, that's it's a quadratic in cos theta. So to solve a quadratic, I have to set it equal to 0. Then we have to factor. And it's almost like the one we did, but I think it's a little different. Right? Got different signs. Okay, so make sure your factorization is correct, right? Because, I mean, if this is wrong, everything down here is wrong. Yeah, it might be done correctly, and then you'll lose like half mark or mark or something, right? I mean, the rest of the work is shown. It's good, right? You've got the idea. You just messed up the... So we've got 2 cos theta minus 1 is equal to 0. And we've got cos theta minus 3 is equal to 0, right? You're just solving, which means this expression is 0 over this. Let's do the right one first. So cos theta is equal to 3. So which of the exact values have a cosine of 3? You say, can't do that. Cosines between -1 and 1. Right, no solution. Nice. Right? All we got to worry about is 2 cos theta minus 1. So what's 2 cos theta? And what's cos theta? Okay. And again, just rewind like 4 weeks ago, whatever the heck it was when we did this, right? So this is the easy stuff now, right? You look back on it and you go, wait, that's not so hard. Okay, so we're in quadrant 1 or quadrant 4. What's theta r? What angle, what reference angle gives you a cosine of a half? Pi over 3, I would hope at some point. Okay, so the reference angle is pi over 3. Okay, so what's theta? Oh, wait, we're in degrees. See how we don't use degrees anymore? Right? Degrees are tough. Okay, so theta r is 60 degrees. So theta is 60 degrees or 300 degrees. Okay, so that's our two angles. Okay, any questions on the first two? Nope, we're good? Okay, so we're using, the first one was really just a pretty straightforward equation. Just rearrange it, right? So you want to solve for sine theta or cos theta or tan theta or secant theta or cosecant theta or cotan theta. Okay, you want to isolate that, and oh, here we go, cotan. 3 cotan squared x minus 1 is 0. X belongs to the reals. Okay, so here, let's keep, here, we'll do this one in radians because it's below the one that's in radians, and we'll do this one in degrees because it's below the one that's in degrees, right? So left side radian, right side degrees. All right, what do we do with this? 3 cotan squared. So what's 3 cotan squared x equal to? 1. What's cotan squared x equal to? 1/3. Yeah. And what's the cotan of x equal to? So it's plus or minus, right? Something being squared. Don't leave off half the solutions. Okay, you don't want to lose half the solutions here, right? Cotan squared is 1/3, so the cotan is plus or minus 1/√3. I'm going to leave it like that, right? Because I'm now going to write, I'm not going to write cotan, what am I going to write? Right? Tangent. So then tan x is √3. So I don't want to rationalize that because then I'll have to re-rationalize it in a minute. Okay, so just look ahead a step and just say, well, we're doing cotan. So now we're going to go to tangent. So I don't want to write this as √3/3 because then it'll be 3/√3 and then I'll have to re-rationalize it and get it back to just √3. Instead we say, hey, we're going to flip this. So okay, so tan x is equal to plus or minus √3, right? So it's in every quadrant. So all we got to do is figure out x ref. And it's in radians, right? So what's x ref? What angle has a tangent of √3? Remember, when we're doing reference angle, it's always a positive. And we said we're in radians, right? So it's pi/3. Pi/3. And then I need that pi/3 in each of the 4 quadrants, right? And actually, well, no, actually we want all reals, but let's sort of sketch it out just so we can, let's visualize this. So I've got pi/3, 2 pi/3, 4 pi/3, because these guys are just apart by pi, right? So we can go with x is pi/3 plus n pi, where n belongs to the integers. And then what's the other? Well, that's 2 pi/3. plus n pi, right? So the n pi gives us the pi over 3 and the 4 pi over 3.
But can't you go half?
Well, so what have we got? We're going to have pi over 3, we're going to have 2 pi over 3, we're going to have 4 pi over 3, and we're going to have 5 pi over 3. Okay, so is there any way to generalize 1, 2, 4, and 5? Like, I don't think we could do it in one, because these guys are pi over 3 apart, but these guys are 2, right? So we can't just make one statement. So we got to go the pi over 3. We can do these two, because they're pi, and then we can do these two. Okay, so x is equal to 2 pi over 3 plus n pi. Okay, I mean, unless you can come up with some general statement which is going to cover 1, 2, 4, and 5, plus, 2n pi on each of those. And I don't think that's possible, right? You can't go plus pi over 3 because you'll hit 3 pi over 3 and you'll hit, and those aren't solutions. Okay, so we have to leave out. We've got 1, 2, 4, 5. We got to leave out 3 and 6, right? So we can't make any statement that would include those. Although we could do this. Say we could go or
Okay, the restriction won't be 3 pi over 3.
well, would this give me a 3 pi over 3? So this is 1 pi over 3. This is going to be 3 pi over 3, right? So this will give me 1, 4, 7, 10, etc. The negative pi over 3, that'll give me the 2 and the 5. So this would work, plus or minus, right? There's plus, there's minus. Okay? I don't expect you to do that, right? So there's no expectation. There's an expectation you do this, or maybe you can do this one here. You don't have to do both. You're not, not responsible for doing this. Oh, hey, this one's simpler or more elegant. Just give me a solution that works. So I'm just pointing that one out. And then what was the other one? We got one more. And if it were degrees, it'd be like 60 plus 180 or 120 plus 180 degrees, right? Or plus or minus 60 plus and 180n degrees. 3 secant squared theta minus 4 is equal to 0. First step. So 3 secant squared theta is equal to 4. And secant squared theta is equal to 4 over 3. And secant theta is equal to? Well, root 4 over root 3. 2 over root 3, right? So take the square root of 4, we get 2, so it's plus. First of all, big thing, it's plus or minus, right? You'll leave out half the solutions if you just go. So anytime you're seeing a squared and you're square rooting to get secant theta, you're also getting plus or minus. Now we're going to leave that because the next line is cos theta, we'll get our root 3 over 2. Right? So we don't want to rationalize this, right? We just want to say, next step, the radical is going to come up top. It's all going to be good. So cos theta is plus or minus root 3 over 2. So the reference angle is what? So we're in degrees. Is root 3 over 2? 30 degrees. Okay, got a reference angle of 30 degrees. Okay, we're drawing down. So you got 30 there, 30 there, 30 there, 30 there. So there's 30, there's 330. So we can go 30 plus 180n, and we can go 330 plus 180n. We can go plus or minus 30 plus 180n. Okay, so same deal as what's over there, really. Sort of the same idea. So we're in all 4 quadrants, right? It's a big thing to remember, we're in all 4 quadrants. So theta is equal to 30 degrees plus 180n. And what's the other one? Well, we won't use 330, we'll use 150. 150 degrees plus 180n. Or you could just say, you can go plus or minus 30 degrees, so this is 4. Plus or minus 30 degrees plus 180n. So what you need to do is just make sure. Will I get a 30? Will I get a 150? Will I get a 210? Will I get a 330? So 30 plus 180 is 210. 150 plus 180 is 330. Okay, it's good. We're going to cover everything off, right? Okay, questions? Easy, right? So just kind of simple equation solving from, junior high, factoring and stuff like that. And then just exact values again, right? And hopefully you're looking at these exact values now and you're going, oh, okay, yeah, it's a lot more familiar. 2 secant x plus 4. So from 0 to 180 inclusive, right? So watch when it's expressed in interval notation, this includes 0 and it includes 180. Okay. This includes negative 2 pi and 2 pi, as well as 0, right? So if 2 pi is a solution to this, so is negative 2 pi, so is 0, etc. All right. So 2 secant x is negative 4. Secant x is negative 2. So cos x is negative 1/2. Okay, we're going from 0 to 180, so where are we? Where cosine is negative. It's in quadrant 2, right? So this is in Q2, only in Q2. What's x ref? 60 degrees. What's a 60-degree reference angle in quadrant 2? 120 degrees. So your only solution is 120 degrees, right? Oh, and then state the general solution. Okay, so that's the specific, and now we got to say, okay, let's go back to here again. Let's just say cos x is negative 1/2. We're going to be in quadrant 2 and quadrant 3. My x reference angle is 60 degrees. So in quadrant 2, it's going to be 60 degrees plus what? So do we go plus 180? No, because that'll take us into quadrant 4 where it's positive, right? We only want the negatives. So it's 60 degrees plus 360n, right? Because we just want that quadrant 2 angle and every angle that's coterminal with it, right? Which is just multiples of 360. And then we need the quadrant 3 angle. So what's quadrant 3 angle? It's going to be 240 degrees, right? 60 degrees into quadrant 3.
It's only for 180.
No. And then state the general solution. And then. The big and then. So that's why I went back down here, right? This is the and then, because I got the 60 degrees, which was reference angle. I put it into quadrant 2, got the 120, say, good, hey, we're done. No, we're not. Okay, now we got to do a general solution. So I sort of redid part of this, right? I mean, that's already there, that's there. I mean, you could do it up here. You could do your general solution. It might be easier. Hey, let's just do the general solution, and then we'll restrict it. So why don't we try that for the second one? So for the second one, we're going to do the general solution. Then we'll just take the restricted, then we'll take the restricted domain and mention that solution. Okay, sort of out of order, but whoa, 5 root 8 and root 18. Okay, so what are we going to do? I could go negative 2 sine theta equal to root 18 minus root 8.
Going back to that one, 60,
yep.
Shouldn't it be 120?
120. You're right. It should be 120. Reference angle is 60. Thank you. It's good. Pointing it out after the. We could fix that before we went on. So negative 2 sine theta is root 18 minus root 8, but root 18 is what?
That's 3 root 2.
So that's 3 root 2. What's root 8? That's 2 root 2. So negative 2 sine theta is equal to root 2. So sine theta is negative root 2 over 2, right? I'm dividing by negative 2. So sine theta is negative root 2 over 2. Okay. Yep. Oh.
So, yeah. I just have a question about 3a.
3a. Yeah.
Could you also write that as x is equal to 180 plus minus 60 plus 50 minus 60?
180 plus
Plus or minus 60.
180 plus or minus 60.
And then plus 360.
180 plus or minus 60 plus 360n.
Like you'd be writing it as 1.
Yeah, I'd probably just go with the 2. You know, like, technically, would that work? I mean, I suppose, right? So 180 plus or minus 60 says you're going to go 120 or 240 and then plus 360n.
Like, say, if someone wrote that as an example.
Okay, what if you did this? So 240 is really just negative 120, right? So I think you're better off just going plus or minus 120 plus 360. And so it's the same idea, right? So if you sketch it out, that's 120 degrees, but hey, that's negative 120 degrees. So plus or minus 120 plus 360n. Okay. Then it's similar to what we had in the other two guys here, right? Plus or minus 30, plus or minus. Just make sure it works. Like run through a few numbers, just satisfy yourself that, yeah, I'm going to get all the values I want and no values I don't want. Okay, so why don't we do the general solution for this and then we can just restrict it. So, but we'll do it down here, right? So we'll go down here and we'll say, okay, so sine theta is negative root 2 over 2. So what quadrant is it in? 3 or 4? What's the reference angle for root 2 over 2? That's going to be pi over 4. Okay, here, let's draw this out. So that's 5 pi over 4. And that's 7 pi over 4. Okay, so the obvious, the one I don't really have to think too much solution is 5 pi over 4 plus 2n pi. Remember, this is general solution. We're doing this first, and then we'll just come up here and state the restricted solution. So it's 5 pi over 4 and 7 pi over 4 plus 2n pi, where n belongs to the I. I don't think we could do a plus or minus 1 because they're not the same, plus or minus, right? It's like 5 pi over 4 and negative pi over 4. So I think we might sort of be stuck with these. So sine is negative in Q3 or Q4. Okay. So what I'm doing is I'm finding my first two solutions, right? From 0 to 2 pi, and then I'm going to add multiples of 2 pi. So what we came down here, we did the general solution first. Having the general solution, we can now just pop up here and do the solution, right? So theta is equal to, okay, so negative 2 pi, right? This is going to be how many quarters?
Negative 5 pi.
This would be negative 3 pi over 4, right? This will be negative pi over 4. And then we've got the 5 pi over 4 and the 7 pi over 4. Okay, are there any more? What's negative 2 pi when you put it over 4?
8 pi over 4.
Negative 8 pi over 4 to positive 8 pi over 4. Okay, so we got a negative 3 pi. Can we keep going in a negative direction? No, because if we go around again, we're going to have gone around. It'll be negative 11 pi over 4. Okay, so there's your solution in the restricted domain of negative 2 pi to 2 pi. Okay? So general solution first, and then we can take the general solution and we can just do the restricted domain, just go up here and just state it. Okay. And actually, I suppose it should be a set of numbers. So let's put it in a set notation. Theta is equal to the set consisting of 2 graphs are shown below. Write a trig equation such that the x-coordinates of the points of intersection are the solution to the equation. Okay, what's this graph? So this is y is equal to 4. What's this graph? Okay, what do we got here? 1, 2, 3, 4. So y is equal to, the amplitude is 2. The middle is here, so there's a plus 5. It's an unshifted cos curve if I just started there, right? So how about 2 cos, what's the period? 2 pi? Good. So it's just 2 cos x. Y is equal to 2 cos x plus 5. Okay. Or you can do it as a sine curve if you wanted, but why throw in a phase shift if you don't need to? So that's y is equal to 2. So you got to figure out the period, right? Okay, period is 2 pi, so the b value is 1. Midline's at 5, right? So plus 5. Amplitude is 2, so 2 cos. It's an unshifted cosine curve, right? You're starting at a maximum, so your unshifted cosine curve, right? If we start here, if you want to do it as a sine curve, you're going to have to kick it left that much. Why would you do that? You don't want to do that. So, trig equation, what do we need? 2 cos x plus 5. So 2 cos x plus 5 is equal to 4. Okay. When is that true? Solve the equation from negative 2 pi to 2 pi. Are they showing us negative 2 pi to 2 pi? Looks like. So we got 1, 2, 4 solutions, right? Which, do we have 1, 2, 3, 4, 5, 6? So we got 2 pi over 3, 6, 7, 8 pi over 3. So we got our solutions, right? Like graphically you can solve, but it says algebraically. So we know the solutions, right? Now we just have to write it. So 2 cos x plus 5 is equal to 4. 2 cos x is equal to 1. Cos x is 1/2. Negative 1. Negative 1/2. It's much better. Better reaction this time. We didn't have quite the delay before the error was pointed out. That's good. It's good. You're getting faster. In Math 31, when these mistakes happen, which will be often, please point them out as soon as you notice them, because it could be 2 pages later, and we don't want to waste a half an hour in 2 pages. Okay, just throw those pages out, crumple up the paper. Drop. Why is there a plastic bag in the recycling? So, where's x? Okay. Where's cosine negative? 2 and 3. What's x ref?
Pi over 6.
Pi over 3, you meant to say? The sine of pi over 6 is 1/2. Okay, so we we need a reference angle of pi over 3. Okay, so let's do this. So we've got, but we're in quadrant 2, so that's going to be 2 pi over 3. We're in quadrant 3, where that's going to be 4 pi over 3. And we're going to go minus 6, so that'll give me negative 2 pi over 3. And we'll go negative 6, be negative 4 pi over 3. And there's your solution. Okay. So I just found these two guys and then just subtracted 6 pi, right? Because we're going negative 2 pi. to 2 pi, or negative 6 pi over 3 to 6 pi over 3. Okay, so 2 pi over 3 minus 6 pi over 3, and 4 pi over 3 minus 6 pi. So you could actually just write this as x is equal to plus or minus 4 pi over 3 and plus or minus 2 pi over 3. Okay, so that will work. Write a Trig. Oh, okay, this is kind of interesting. It's a variation now. We got to write an equation that has solutions of n pi over 3, where n belongs to the integers. Okay, so let's sketch this out. Okay, unit circle. Okay, so what's the first pi over 3? So n belongs to integers. What's the lowest value for n? Let's just stay 0 pi over 3, right? So we have 0. So here's a solution, right? Which is where? This is at 1, no, 0, no, it's at 1, 0. Okay, then what's the next pi over 3? 1 pi over 3, right? So 1 pi over 3 has coordinates of what? 1/2 and root 3 over 2. What's the next pi over 3? 2 pi over 3. Okay, so there's 2 pi over 3. So 2 pi is just a reflection there, right? So negative 1/2 root 3 over 2. What's the next pi over 3? That's right, 0 pi. So we got 3 pi over 3, which is just pi. So what's that at? Negative 1, 0. What's the next pi over 3? 4 pi over 3, right? After 3 pi over 3 comes 4 pi over 3. And 4 pi over 3 is just negative 1/2 negative root 3 over 2. And then we got 5 pi over 3, which will be at 1/2 and negative root 3 over 2. And we got 6 pi over 3, and we just keep going, right? After that, it's... Okay, so write a trig equation. Now, you can write a trig equation in terms of sine or in terms of cos, so we'll do both. So let's just start with in terms of sine theta. Likely on a test we would say in terms of and then give you a particular one, right? But here we didn't say, so let's do in terms of sine theta. Okay, so then what do we know? We know that sine theta is equal to 0. Or sine theta is equal to plus or minus root 3 over 2. Remember, sine theta is the y coordinate of the point on the unit circle. So, you now have sine theta equals 0, so sine theta is just one of the factors, right? So if you write in factored form, okay, so in factored form, okay, factored form is going to be sine theta times, now, what's going to give us a factor of sine theta equals plus or minus root 2 over 3? Yeah, okay, theta. So let's just think, okay, what does that mean? It means sine squared theta is equal to 3/4. Which means 4 sine squared theta is equal to 3, and 4 sine squared theta minus 3 is equal to 0, and that's my other factor, 4 sine squared theta minus 3. And that is equal to 0. Okay? So that's a factored form of the equation, and if you wanted the unfactored, it'd be 4 sine cubed theta minus 3 sine theta equals 0. But I think we could just leave it in that form. So in terms of sine theta, this is two solutions, right? There's where sine theta is equal to 0, or where sine theta is equal to root 3 over 2, or where sine theta I mean, you could actually have ended up writing 2 sine theta equals root 3, right? So you would end up with 2 sine theta minus root 3 and 2 sine theta plus root 3, and you'd multiply them out and get 4 sine squared theta minus 3. Because we would never leave a root sitting in there. So what if we do cos theta? So in terms of cos theta, so cos theta is plus or minus 1. Right? So cos theta can be 1, or cos theta is negative 1. So that means that cos squared theta is equal to 1, or cos squared theta minus 1 is equal to 0. So one of my factors is cos squared theta minus 1. And then what else do we have? Cos theta is equal to plus or minus 1/2. Right? It's the x value. So half, negative a half, negative a half, a half. So same deal, right? We're going to square this. Get cos squared theta is equal to 1/4. So 4 cos squared theta is equal to 1, and 4 cos squared theta minus 1 is equal to 0. So the other factor is 4 cos squared theta minus 1, and the product of those two factors is 0. Okay. And then all you do is you work your way backwards. Yep.
Can you explain why you squared it?
Yeah. So, you could do this. So you could say, all right, cos theta is equal to 1, so cos theta minus 1 is equal to 0. So there's one factor, right? Cos theta minus 1. And then you would say cos theta is equal to negative 1, so cos theta plus 1 is equal to 0, right? So here's a factor, here's a factor. You could say cos theta is equal to negative 1/2, so that'll work out to 2 cos theta plus 1. And you could say cos theta is equal to 1/2, which gives you 2 cos theta minus 1. So here are your factors. 2 cos theta minus 1, 2 cos theta plus 1. Okay, and I've really just combined these. So cos theta minus 1, cos theta plus 1 gives you cos squared theta minus 1. And 2 cos theta plus 1, 2 cos theta minus 1 gives you the 4 cos squared theta minus 1. Okay, so I guess here's the deal. If it's equal to a plus or a minus, squaring both sides is just going to give you a positive on the right-hand side, which gives you basically a quadratic factor, right? Cos squared theta minus 1. And here, cos theta is plus or minus 1/2. So again, you're doing it to get rid of the plus or minus. You square both sides, plus or minus is gone. We've got this. The solution to this is these two guys, right? Because it'll become 4 cos squared theta minus 1 is 0, which will become 2 cos theta plus 1, 2 cos theta minus 1. And here, I mean, I suppose here the reason you could write sine theta is, how did that go purple all of a sudden? I'm not
That
doing
marker is kind of out, so it keeps going back.
Yeah, something. This will be 2 sine theta minus root 3. We generally would not write that as a factor. And the other factor is going to be 2 sine theta plus root 3, so we just get 4 sine squared theta minus 3. Okay. You generally don't want to write a factor that's got a root in it. Okay. So when you've got sine theta is plus or minus, you square both sides. So that's over here, right? It came over here. Square both sides, get this factor. This basically becomes to, you're basically just going to work it backwards. You're going to go from this, go to this, go to this, go to this, and then state your solutions. Is there more exercises? There you go. Excellent. Okay, so watch your restriction on it does not include 0 degrees. Okay, so if the solution is 0, you're just going to be saying 360. right? Because those are coterminal. But you're only going from not including 0 up to and including 360, not including 0, but including 2 pi, and that's for everything but A2 and A5. Okay, and then the answers will be in that form. Okay, and then answers must be on the next page. Here are your answers. Okay, so restricted domains, and here's general solutions here. And